biology behind soil structure is really, really important. And the example here is as I came in today, we're looking at some fields right next to town here. So it's right in my backyard. Pulled some samples, brought those in, and we're going to look at that soil structure here today very quickly. One of these samples is actually a no-till field that's been no-till for almost 20 years now. It's been a corn, soybean, wheat rotation with a cover crop after that. And it has some really interesting characteristics, but also visually it's really pretty interesting. In turn, that the clod that you have over there is same soil. It's an innit soil, just across the fence down the road. Kind of really interesting to me. It's been in a corn soybean rotation for probably the last 15 years. It actually had wheat in it before that. Been really a conventionally tilled, and conventionally tilled around here is using a vertical tillage tool. This is a sulfur in the spring, but structurally looks a lot different. Does not have the cohesiveness that we actually see, that aggregate stability that we see. Maybe we should immerse these clods and just see what kind of differences we end up with here.
Let's do it.
All right. Immediately what we're going to end up with is we're going to see the air come out of that clod. The water is going to be rushing in. But at some point, immediately, you're actually going to see that those polysaccharides, those glycoproteins are missing in that conventionally tilled sod, or that soil. They've been mineralized, oxidized, and because of that, it just really falls apart. That raindrop impact on that soil surface will really dissipate that surface, really start to move that soil surface around, and as Dr. Tom was talking about before, really start to plug some of our macropores, intermediate pore sizes within that matrix, and really increase runoff. Huge difference. And this has everything to do with people saying, well, this, I can't do this no-till thing. Well, that first year of no-till, they don't have any soil structure. It's super saturated in that surface. It's a mucky mess. They can't get planted, and guess what? It doesn't work. Guess what? This is our tabletop rainfall simulator. It really is kind of a nice simulation because it's actually taking a 3.5-inch sample right out of the field and gives us a really good handle on soil structure and infiltration. So we like to use this, and in fact, why don't we go through and actually do this demonstration. This is a innit loam. This is a long-term no-till with, of course, it's got a rye cover crop on it. And then this soil structure over here has been destroyed with tillage, long-term tillage, conventionally tilled, corn, soybean rotation. Structure is just so much different. And of course, this little test actually shows us that differences in infiltration and runoff.
So just to be clear, both of these are innit loams. So
innit loams, yeah.
But same soil series, different management.
Exactly, yep.
All right, well, let's do this.
All right, we're going to put this infiltration tray up on the top. Get that leveled out. And then it's just a matter of adding water. So we'll go ahead and do that.
Wow. So what's happening now? Oh my goodness.
Well, I think you can see there's a substantial difference.
Yeah.
And in fact, it appears that all the water in that runoff in the conventional till is basically run off, and you can see the differences in the color. That is the amount of sediments that's actually removed, and it's hard to see. But you can see there's a large amount of infiltrated water here, and there's really no infiltrated water over here. And that's really what we see, and when we start talking about soil structure, what makes it so important.
I didn't actually expect that everything would run off. There's literally one drop in.
Jeff,
that's amazing.
You just did the infiltration test, really phenomenal results. This is the next part of it. What are we going to be doing here?
Well, and I think this is really the more important part, is that we're really looking at the soils. These are, again, that innit soil, both the same soil, except this, of course, has been managed a lot different. No-till, long-term no-till. You can see they have a rye cover crop on it, conventional till. But what we want to do on both of these samples, first of all, is just pick them up and really look at that soil structure and what happened on the bottom. And if you look at that sample, you can see here that we didn't infiltrate any water. It's really dry on the bottom. Where here we've got really wet conditions, etc., it infiltrated that water. We've got that macropore development, those wormholes coming all the way through that sample based on biology. It's about soil structure. So let's push them out and go from there.
All right. You ready? Oh, come on. So you've given me the tough one here.
Yeah, that's give me the one again.
It's actually coming out. Okay. Whoop. Oh.
In chunks.
Okay, so is that platy structure right there?
Well, you know, for the most part, you're really looking at it has really poor structure. It's massive, maybe subangular blocky, platy on the surface, but it's really muddy and super saturated on that surface. I don't know if you could really see that. You got platy soil structure, you can see that right here, really pretty obvious.
Right.
If you really start looking at, compared to this one, and we can turn this around a little bit, you can see the roots, but you can also see here how,
oh my goodness,
how granular that structure is compared to.
Yeah. Okay, so
you got really nice granular structure.
So that's basically pore space. That's where the water in the air is going to go through.
Absolutely.
And well, there's not a pore space. You know, you can't see them. It's all
no wormholes.
Yeah, no wormholes.
No wormholes. Some pore space. It's about structure. That's how it is really the situation of the issue here. So.
Okay, well, this is a great illustration. Thank you.
So maybe we should actually look at some soils. What do you think?
I like the idea.
Well, let's see what we have. Well, I don't know what kind of jumps out at me is a really nice structure, but there's really some soil life here. What do you think?
I think so. Yeah.
Look at that.
Earthworm. Beautiful. Yeah, look at that. So we've got, I can count 3 individuals right there.
Yeah, see that?
Yeah, 4. And then plenty of soil structure.
It's really nice macropores.
Yeah.
And then, you know, we underestimate that duff layer. You see that on the top. It's just so important to have that.
So that's your soil armor.
You bet.
And that then also keeps the temperatures a little bit warmer in the winter, is that right?
Absolutely. You bet.
Yeah. Okay.
Well, the other thing too, you know, you're looking at that rise, is that root system, that fine root system really aggregates things really nice. So.
Yeah, it is. It's gorgeous.
So maybe we should take a sample of this over to the other
let's do
location.
That. Okay.
Oh, cool. Do it.
All right. Okay, tell us about this field.
Well, you know, this field actually was tilled up about 10 days ago. It's an annate soil. It's the same annate that we were looking at in the inside. Yep. And what's interesting to me is you go out here, you take a spade full of soil, and people look at that and say, well, that looks fine, that looks great. There's nothing wrong with that. The other problem is they don't have any context. So we went over and got the annate soil the way it was supposed to look, and look at the organic matter differences. I mean, you don't have to be a soil scientist to figure out this. And look at the soil structural differences. You can see that you've got really nice granular structure in this sample, how deep that organic matter actually looks like. And this thing, we've tilled it up, and we've actually got subangular blocky. It's really fluffy on that surface. It's broke down really, it crusts over really a lot on that surface. You can see that crusting from that raindrop impact.
Right.
But you know, to me, that's a real interesting thing is just how much stark difference that is in the organic matter. Just comes right out at you.
Yeah, no, definitely. And then you also pointed out about the weeds.
Well, yeah. We talk about that all the time. The weed pressure that we have out in fields, etc. And yet we're building that weed seed bank out here. And how are we doing that? Well, we're burying in this particular case, resistant kochia. Then we're tilling it down. We're gonna get rid of it. Well, then it comes right back at us again. And this was 10 days ago, and it flushes again on us.
Yeah.
So is tillage really the solution to weed management? No, it's not.
In fact, it's the opposite.
Absolutely, it is the opposite.